All right, our last speaker is Dr. Jeff Coulter. Jeff is a professor and extension agronomist at the in the Agronomy and Plant Genetics Department. His research is focused on identifying and understanding agronomic practices that increase crop profitability, productivity, and sustainability in corn-based cropping systems. And congratulations to Jeff. This fall, he was named ASA Fellow, which is a big deal. Congratulations. Thank you.
Okay, good afternoon, everyone. It's great to be here. I'm going to talk about short stature corn and some implications for nutrient management. So corn is one of the last cereal crops yet to be shortened. If we look back in history, semi-dwarf wheat and rice varieties that were resistant to lodging and diseases were the backbone of the Green Revolution that occurred in the 1940s and 1960s. And if we look at the other crops, a lot of other cereal crops, most of them have been shortened. Some examples include grain sorghum, barley, rye, and pearl millet. There are a lot of advantages of semi-dwarf cereal crops. The main one is less lodging because you got a lower center of gravity. You also have greater tolerance to high plant populations. And by having that greater tolerance to high plant populations, that gives you higher yield potential. And some research that's been done is showing that plant population has been a driver of the increase in corn yields over the last several years. One of the most well-known studies looked at corn hybrids that were released between 1987 and 2016, and they found that 8.5 to 17% of the yield improvement over time for the new released hybrids was due to those hybrids having higher optimum plant populations. So short stature corn hybrids are now starting to come out. People are excited about it. Stein Seed Company was one of the first to offer short stature hybrids. And currently about 1/3 of their hybrids are considered short, which would be 7 feet or tall or less. And in comparison, the tall or standard hybrids are typically 9 to 12 feet in height. In addition, the short stature hybrids generally have higher optimum plant populations, which, as I said earlier, gives you greater potential for higher yield. In addition, other companies, all the major seed companies are developing short stature hybrids. And just as an example, Bayer had 85,000 acres of their hybrids, short stature hybrids, planted in 2025, and they anticipate 200,000 acres in 2026. So what are some of the characteristics of short stature hybrids? The first one is that they have shorter height, obviously, and that's due to shorter internodes or shorter distance between the leaves. And that becomes more visible out in the field once you get about the V8 stage. In addition, depending on the company that you're working with and their genetics, we oftentimes see lower ear height. And in some cases, the lower ear heights have been a little bit problematic with harvest, especially on droughty areas, sandy knolls, that type of thing. There's some other noticeable characteristics of short stature hybrids. Generally, they have shorter and wider leaves, especially near the middle of the plant. They also have more upright leaves, which allows the sunlight to penetrate a little bit deeper into the canopy. And oftentimes they have similar leaf number compared to standard tall hybrids. And as I mentioned earlier, they have that higher optimum plant population. Other characteristics are they have smaller tassels, which again are going to allow more light to penetrate into the canopy. But when they're planted at the same population, oftentimes they have similar ear size. These are pictures from the 2025 field school that we had on the St. Paul campus. We had a 105 maturity short stature hybrid planted next to 108 relative maturity standard hybrid. And you can definitely see that the tassels on the left side from the short stature hybrid are smaller. They don't have as many branches, and the ears are about the same size. But another thing that's exciting about the short stature hybrids is they have great potential for corn silage. In Minnesota alone, we're looking at probably several 100,000 acres of more silage corn being needed in the next decade, mainly in west central Minnesota due to the expanding dairy industry. The short stature hybrids, they offer some benefits or potential benefits when it comes to thinking about corn silage. One of them is because they're shorter, they got less stalk. And in the stalk, there is a lot of lignin. And lignin is kind of like rebar in concrete. It helps to give the plant structure. But that lignin is also the part of the fiber that's not digestible. So It's not, if you have a lot of that in your silage, the cows aren't going to eat as much. In comparison, if you cut at a higher cutting height, or if you use short stature hybrids, which have less stalk, now you have less stalk material in the silage, which means that it's going to have less of this lignin in there. So the cows are going to be willing to eat more and therefore produce more. However, some of the research has indicated that the short stature hybrids have a little bit lower yield potential than the standard dual purpose tall hybrids. One of the studies that was done was by the University of Wisconsin in 2024. And I think they repeated the study in 2025, but I haven't been able to find the results yet. But anyway, the results from the 2024 study, they looked at comparing two brown midrib hybrids, which are kind of the gold standard for digestibility of silage. They also compared that with five dual purpose hybrids, which can be used for both grain or silage. And then they also compared that to 5 short stature hybrids. And in terms of grain yield, or in terms of whole plant dry matter yield, they were looking at levels between about 12.5 to 11.5 to 12 tons per acre. And they found that highest whole plant dry matter yield occurred with the dual purpose hybrids, and the lowest occurred with the brown midrib hybrids, which is kind of what we already know. But then they found that the short stature hybrids were kind of in the middle. Their whole plant dry matter yield wasn't significantly different than that of the dual purpose hybrids, but at the same time, it wasn't significantly different than that of the brown midrib hybrids. Another thing that they looked at was the starch concentration of the silage. So with these short stature hybrids, you have less stalk, but if you have the similar grain yield, that's going to mean that you have a higher concentration of grain in the silage. And since the grain is largely composed of starch, that's going to be a greater percentage of starch in the silage. So they found that the short stature hybrids and the dual purpose hybrids had a similar starch concentration, and that it was higher than that of the brown midrib hybrids. They also looked at the digestibility of the silage, and they found that the short stature hybrids, again, were somewhat in the middle. The best digestibility was with the brown midrib hybrids, and the least was with the dual purpose hybrids. So it does look like these silage hybrids these short stature corn hybrids have great potential for corn silage, especially now as we're looking into the future with the brown midrib hybrids being phased out. So I expect that there will be a lot of silage acres being planted with short stature corn in the coming years. Some other characteristics of the short stature corn is that they have thicker stalks. So this is, again, pictures from the field school this last year. Corn on the left was the short stature corn with a very thick stalk compared to a representative plant of the standard hybrid. Very noticeable differences in stalk diameter. They also have thicker nodal roots. If you dig a plant and you start to knock off the soil around the roots, you'll see that those nodal roots are much thicker in the short stature corn. And in addition, it's also darker green up through the V6 corn stage. I've observed that at a couple different places, and I've heard other people report on that as well. So it makes me think that there are some implications for nutrient management. And this is a kind of a close-up of the difference in the nodal roots. You see the picture on the left, a little bit thicker nodal roots than the one on the right. And you can definitely verify that if you dig one up. There's many other benefits of the short stature corn. I mean, I mentioned earlier the greater resistance to lodging because you got that lower center of gravity. Another one is they allow easier in-season applications with ground-driven sprayers, and they got a larger and deeper root system. And again, they have that higher optimum plant population. So there hasn't been a lot of research done on this because it's kind of a fairly new thing that's been coming out, but there has been a few studies published from Purdue University in Indiana and also from the University of Illinois in Illinois. And it's been some very good work, and some of it has involved nitrogen rates and nitrogen timing. So I kind of will talk a little bit about that, and we'll kind of use some of that as kind of a indication as for what this may mean as we go forward in thinking about nutrient management. So one of the studies was done near Purdue University in West Lafayette, Indiana, at West Central Indiana. They had clay loam soil there, very similar soil to what we have in southern Minnesota. In this study, they planted the corn and corn following soybeans. They fertilized according to regular extension guidelines, except for nitrogen. And then they planted the corn at 42,000 plants per acre was their population. They used 30-inch rows in conventional tillage, and they used 3 N rates. They used a 0, 150, which they considered kind of a normal standard N rate, and then they considered 200 pounds of N per acre, which is an elevated nitrogen rate. And they applied those as liquid 28% UAN after planting. It was injected. And in this study, they compared 2 short stature corn hybrids and 2 standard stature hybrids of the same genetic families. And some of the findings that they found was that compared to the standard stature corn, the short stature corn didn't yield significantly different at any of the N rates. The yields were similar between the 2 hybrid types at all of the 3 N rates. However, they did find that there was a 3.5% greater nitrogen harvest index for the short stature corn, and that was statistically significant. The way that you calculate nitrogen harvest index is the grain N content divided by the total above ground plant N content. So by having a greater N harvest index, that means that there was a greater percentage of N in the grain compared to the whole plant. And that's an indication that there may be greater remobilization of nitrogen into the grain with these short stature hybrids. In addition, some of the more interesting findings are that there was a 20% greater total above ground N uptake from silking to maturity for the short stature hybrids. So that's fairly noticeable, 20% more N uptake after silking. And in addition, when they did the calculations at the end of the year after harvest and after looking at the N uptake in the plant, they found that the short stature hybrids had 18.5% greater recovery efficiency of applied N fertilizer. So this could be advantageous for many reasons. If you have greater N uptake, that means potentially less residual nitrogen in the soil to be lost. It could be also beneficial if it was in a field that had, say, a manure application and we were getting mineralization throughout the year, and maybe there had been manure applied several years in a row. By having that short stature corn in there with the greater N uptake potential, you could take that up better and then potentially have less available for loss. In addition, the authors concluded that some other things, they thought, well, with this short stature corn, maybe it won't be as sensitive to nitrogen stress after silking, since it's got better N uptake. Maybe it'll be kind of able to ride some of these waves in nitrogen availability a little bit easier. In addition, they concluded that the short statured hybrids may be better able to take up N applied in the season than the standard stature hybrids. And as I mentioned earlier, they thought that the short stature hybrids could reduce residual soil nitrogen after harvest, which is susceptible to loss, even though they didn't measure that. So some kind of encouraging results on the short stature corn, at least from a nitrogen standpoint. Another study that was done, this was kind of one of the first ones that was ever published. This was done in Illinois and Indiana, and they had 10 different trials over 8 site years. And a site year is a combination of a year and a location. And they were working on silt loam and silty clay loam soils. And they were comparing 8 short stature hybrids and 6 standard stature hybrids of the same genetic families. And the number of hybrid comparisons that they had in a trial varied by the trial, but they were always comparing within the same genetic family, short stature versus standard stature hybrids. And they were planting populations for the short stature corn at 42,000 plants per acre. And they were also using that for the standard stature hybrids. But then in some trials in Illinois, they used 36,000 for the standard hybrids and 42,000 for the short stature hybrids. And again, corn following soybean, 30-inch rows and conventional tillage. And in this study, they were looking at a total N rate of 150 pounds of N per acre for corn following soybean. And they were looking at 3 different nitrogen treatments. One was the 100% N rate at planting, 50% planting, followed by 50% N at the V6 stage. And then they were also looking at a split with 50% at planting and then 50% at the V12 stage. Some of their findings were that compared to applying all of the N near planting, they found that splitting the application with half of the N at the V6 stage, that increased yield in 60% of the trials for the short stature corn and in 50% of the trials for the standard corn. So about the same, but they were getting a response to this split application in about half of the cases. In addition, they looked at the scenario where they apply 50% at planting and 50% at the V12 stage. Now they were again finding some yield increases due to the split application, but it wasn't as consistent. It was on only 25% of the trials for the short stature corn and 50% of the trials for the standard corn. And again, remember that there was only like 10 site years here in this trial, or in this study. So they were somewhat limited on the number of trials that they had done this on. So we don't want to look at these numbers too closely and try to, make too strong a conclusions out of the differences. But anyways, they were noticing some differences in the hybrids. Some of their main findings across all of the 10 trials were that compared to the standard stature hybrids, the short stature corn had about 4% less total above ground biomass at maturity. So the plants were a little bit smaller. Again, the plants also had 4%, the short stature corn had 4% greater harvest index, which means that even though they were a little shorter, they had a greater proportion of their above ground biomass as grain compared to other plant parts when compared to the tall corn. In addition, as found in the previous study, they found that the short stature corn had 3% greater N harvest index, which again is the proportion that's in nitrogen that's in grain at maturity compared to the whole plant N content. So again, it looks like the short stature corn has a little bit greater potential for remobilizing nitrogen into the grain at the end of the year. And also they found that the short stature corn had greater recovery efficiency of applied nitrogen fertilizer in 2 of the 10 trials. So again, some encouraging results. And if we kind of summarize those again, they were finding yield increases with the split N application, but those yield increases were more common when the split occurred at the V6 stage rather than V12, which is exactly what we would expect if we were in Minnesota. And then they also found that the short stature hybrids generally had a little more frequent yield boost for the split application than the standard stature hybrids when the split was at planting and at V6. And also they found that the short statured hybrids were a little bit smaller, but they had a higher harvest index and again, greater remobilization of N to the grain. And so there are some potential benefits. Some people had speculated prior to these papers on this slide that some of this may be due to differences in root systems, but measuring differences in roots is very complicated, very costly, time consuming. We generally don't know a lot about roots compared to the above ground portion of the plant. But there have been a couple more recent papers published on this, and one of them looked at 11 trials in the central corn belt between 2020 and 2023, and they found that the short stature hybrids had 39% greater root volume than the standard stature hybrids. And then another study that was from Purdue University that's I think still ongoing, they found that the short stature hybrids had 35 to 42% greater total root biomass and a deeper root system than the standard stature hybrids. So there's many benefits that could come from this. But there's also been other work that's been done looking at high yield systems and how high can we push the yields in short stature corn with looking at various factors like planting rates, row spacing, fungicide, all kinds of things. And some of the key findings that have been found and that have been repeated in multiple studies is that the short stature corn hybrids can yield more when they're planted in 20-inch rows. They seem to have a greater yield response due to the narrow rows than the standard stature corn. In addition, they found that when this short stature corn is planted in the narrow rows, it has a higher optimum plant population than it would if it was in the 30-inch rows. And in some cases, the optimum populations when in narrow rows have been between 40,000 and 52,000 plants per acre. So it's kind of a different system than what many growers have been used to, but I think it offers great potential. And if we look at the history with the other crops, I think it looks like this is the next step forward as we try to further increase corn yield. Has been a couple other studies done on short stature corn, again from Indiana. One study was done in 2023, and it was corn following soybean, and they had 4 nitrogen rates going from 160 to 280 pounds of N per acre in corn following soybean. So definitely a significant amount of nitrogen fertilizer going on there. And at that was done at one location. And at, and at, excuse me, and at that one location, the short stature corn and the standard stature hybrids both had similar yield response to the nitrogen rate. But part of that could have been due to having so many N rates above what would be needed to maximize yield. In the 2024 study, those same researchers repeated the study, but now they had included some lower nitrogen rates. Now their rates range from 0 to 270 pounds of N per acre. And in one of the two studies, they found that the short stature corn needed less N to maximize yield. But they also, in that one study, they also had greater lodging of the tall corn in that study. So they thought that, well, maybe part of that is due to the lodging and that the tall corn had greater lodging. So it may not be completely due to the hybrid type. So I think they're repeating that again. They repeated that again in 2025, and we're waiting to have the results available to us. But that's kind of what's been found so far. But still, at this point, there hasn't really been a clear study that's had multiple N rates at, say, small intervals to really focus in what is the economically optimum nitrogen rate, what is the economically optimum rate for other nutrients as well for the short stature corn. So that's something that needs to be kind of figured out. And then also, if farmers end up planting this in narrow rows and at high populations, is that further going to influence what the optimal nutrient rates are? Some other questions that remain is, how is the short stature corn going to respond to starter fertilizers, especially if it has a more vigorous root system, if it's darker green earlier in the season? What does that mean? Is this, how is it going to respond to starter fertilizer? And then another question that I have, it's interesting to kind of look back at the last 10 years and see what has happened in the industry with regards to row spacing for corn and also the use of the 360 Y drop system for corn. But, it looks like the short stature corn is a good candidate for narrow rows and in-season application of N. So it makes me wonder, are farmers going to start adopting narrow rows coupled with later side dress applications using this 360 Y drop system? So I think there's lots of opportunities to do some on-farm testing and try to see what we can do to push yield. But some of the yields that I've seen from Indiana in these trials look very encouraging in the upper 200 bushels an acre or so. So it's quite impressive yield levels. And I think there's a lot of work that is going to need to be done to kind of fine tune the system, but it definitely looks like it has potential. So with that, I just want to thank our sponsors, the USDA National Institute of Food and Agriculture, and also the Minnesota Ag Experiment Station. And with that, I'd be happy to take any questions. Okay, first question says, when will early maturity short corn be available? Something in the 90 to 95 day relative maturity. I don't know. It seems like at this point, most of the short stature corn is somewhere in like the 102 to 115 relative maturity range. So I haven't heard of any in that early maturity range yet that's available. Another question that we have is, how do intense weather events affect these short corn varieties? Do they weather these events better? Yes, they do. Was a study published when they had that derecho that went through Iowa a few years ago, Iowa and Indiana and Illinois, and they found that the short stature corn stood very well, and the tall corn had a lot of lodging. So that's could be a very important thing. This year at Waseca, Minnesota, we had some severe stalk lodging that occurred when we had high winds that occurred right when the corn was at the VT stage, right at tasseling. So that was very severe. So it looks like that's going to be a key benefit. Another question that we have is, what is or what will be the recommended seeding rate and row spacing for short stature corn in Minnesota? Well, I don't think we've done enough work to define that, but just kind of surveying the literature, it looks like probably a minimum planting rate of around 38,000 seeds per acre is probably going to be minimal, and it could go into the mid 40s. And if you're in short or if you're in narrow rows, it could go even higher. But, I think that's something that we need to do some further work on. Any other questions?
I just wanted to say, I don't know if somebody wants to represent Bayer here, but I'm a Corteva guy. Just remember, both parents are transformed, correct? Bayer's concept, they're starting with a native trait, they're backing it up with a GMO. Our concept is more of a GMO and then going to a native trait, but ours isn't out there probably because of the GMO status. We think at least the same yield. And this is something everyone needs to remember. The reduction in the incidence of wind injury is reduced by 90% in the research that's been done. Standard or increased ear prolificacy. The cultural practices, there's two things working against one another. It definitely has potential for yield. Jeff Graham, who leads our international breeding effort, believes this is the platform that we will be putting out 300 plus bushel corn. So it looks like they're pretty positive on it. But as you know, nutritional health and doing touch-ups in high intensity corn means you need to be in the field during the season. So culturally, we may go to 20-inch rows with tram lines, but 30-inch rows would make sense as well, just for access to the crop. So we've had, you've seen it in the field, especially the Bayer concept in 23, which was the second year of a drought year, and the ears were very low. And in 24, it was an epic wet denitrified event, and the ears were very low. It looks like it'll have a fit in the central part of the Corn Belt where we're fairly productive, but on the peripheries with not as good as soils or water holding capability, probably not. So most productive areas of the Corn Belt. So one thing that they didn't anticipate, and I think it's slowing the whole system down, is the transformed male and female for seed production. The female is putting the ears very low, and that needs to be figured out. So that's kind of all I know. We got updated last week on the whole concept.
Great. Thank you, Dave. That was very helpful. Has anybody else had experience with short corn, and what were your experiences on it? Yeah.
Well, no, very low means it may be touching the ground.
Yeah, the question is what do we mean by very low ear height? And Dave said it could be touching the ground. I think in a lot of cases, the researchers were measuring that the ear height, or the point where the shank connects to the stalk, was like 28 inches on average. But at the same time, they say that you want that to be about a minimum of 30 for ease and harvestability. So we got a little bit to go. Yeah, I can. I think they're actively working on that. That's the key thing that all the farmers that have tested it are complaining about. So I think that's high on their list. Yeah. Yeah. So the question is we noticed differences in root structure, but what about like pests, those type of things? There's been a lot of like fungicide trials in short corn versus standard corn, and kind of the early indications were that the short corn would be more responsive to foliar protection fungicides than the standard stature hybrids, maybe because it doesn't have the disease package built in. But the results have been variable, and I think it kind of depended how much disease pressure there was. In a lot of cases, they have the same traits for below ground and above ground insects that the standard corn has. So I think the key thing will be to keep an eye on the need for fungicides for disease control. Okay, a couple more questions. Maybe I missed it, but if the plant is short, is uptake of NP and K significantly less with the smaller plants? No, I don't think so. I think it's about the same, or maybe a little bit greater with the short stature corn on a I think the thing is that the short stature corn, it's a little bit smaller. Like on a proportion basis, it probably takes up a similar amount, but it's just a smaller plant. But then if you get a higher population, that kind of offsets it. So I think the uptake overall is going to be probably similar for the nutrients, but it looks like with the greater root system in the higher population and what was found in some of the studies, it looks like the short stature corn does have greater N uptake for sure. So I would guess it would probably have greater P and K uptake as well by a little bit. So there's a whole bunch of research that could be done to study the nutrient cycling and dynamics with this. But I think it's pretty exciting, and it does offer a lot of potential benefits for nutrient management and environmental quality. Another question is you mentioned well above 200 bushel for yields. What can a grower expect for tons per acre used in corn silage? So yeah, in some of the Indiana trials, I mean, like there were yields of 290 bushels an acre in corn following soybeans. So I think it has very good yield potential. The silage study that was done in Wisconsin at Lancaster, Wisconsin, had very high silage yields reported in it. I think that in that study, they reported that the yields were around 12 tons of dry matter per acre, which is very respectable. So I think the short stature corn in terms of corn silage is probably going to always yield a little bit less than the dual purpose hybrids, but I think it's going to be respectable, you know? So I don't think we're going to probably see a super huge yield reduction when compared to standard dual purpose hybrids. And a lot of the silage farmers that are growing dual purpose hybrids are now thinking about cutting their stalks higher to get less stalk in there, because that lower stalk has a lot of lignin and is not very digestible. So if they start cutting their silage hybrids taller, now their yield is going to be coming closer to that of the short stature corn. Any other questions or comments? Yeah. Yeah, how about drought tolerance? Well, based on those data that's looking at the root volume and the rooting depth and how they were reporting substantially greater root size and depth for the short stature corn, I would guess it would be able to tolerate the drought stress better than the standard stature hybrids. But right now, what we've been seeing in the trials that have been going on is whenever there's drought stress, the ear height gets lower than what it already is, and often so low that it's just not harvestable. So right now, with the low ear height problem, when we have drought stress, it basically renders that ear unharvestable in many cases. But if we can get that ear to be up higher on the plant, then I think that it should be more tolerant to drought stress.
Any other questions for Jeff? Good. I think we're done. Thanks
Okay,
very
thank
much.
you.